Data analysis and statistical techniques. Mastering data analysis, statistical tools for management decisions. Introduction to data analysis. Data analysis definition. The process of collecting, organizing, and interpreting numerical data to support decision-making. Importance in management accounting. Helps businesses make informed decisions based on evidence. Identifies trends, patterns, and relationships in financial and operational data. Improves budgeting, forecasting, and performance evaluation. Reduces uncertainty in business planning. Data analysis transforms raw numbers into actionable business insights. Understanding data types. Qualitative data, descriptive data. Non-numerical information describing characteristics. Examples: customer feedback, employee satisfaction ratings, product reviews. Provides context and meaning to numerical data. Quantitative data, numerical data. Information that can be measured and expressed in numbers. Examples: monthly sales revenue, production output, costs. Comparison table. Qualitative, employee feedback, good service. Quantitative, sales revenue, $10,000. Data sources. Primary data. Collected directly from first-hand sources. Examples: customer surveys, employee interviews, direct observations. More expensive but highly relevant to specific needs. Secondary data. Collected from existing sources and databases. Examples: industry reports, government statistics, published research. Less expensive but may not be perfectly tailored to your needs. Strategic application. A company surveys 500 customers, primary data, about preferences. Also reviews industry reports, secondary data, for market trends. Combination provides comprehensive market understanding. Data collection methods. Observation. Watching and recording activities systematically. Example: monitoring production line efficiency for bottlenecks. Questionnaires and surveys. Collecting structured responses from targeted groups. Example: customer satisfaction surveys with standardized questions. Interviews. Conducting open-ended or structured conversations. Example: feedback sessions with department managers. Internal reports. Using existing data from accounting systems, sales records, HR databases. Most cost-effective method for routine analysis. Data presentation techniques. Tables. Organizing data in rows and columns for easy comparison. Best for detailed numerical data presentation. Charts and graphs. Bar charts, comparing different categories or groups. Pie charts, showing proportions of a whole. Line graphs, tracking trends and changes over time. Scatter plots. Showing relationships between two variables. Helps identify correlations and patterns. Monthly sales data presented using line graphs reveals seasonal trends effectively. Measures of central tendency. Mean, average. Formula: mean equals sum of all values divided by total number of values. Example: sales for 5 months, 10, 20, 30, 40, 50. Mean equals open parenthesis 10 plus 20 plus 30 plus 40 plus 50 close parenthesis divided by 5 is equal to 30. Median, middle value. The middle value when numbers are arranged in order. Example: 5, 10, 15, 20, 25. Median equals 20. Mode, most frequent value. The value that appears most often in the dataset. Example: 3, 3, 4, 5, 6, 3, 7. Mode equals 3. Measures of dispersion. Range. Difference between highest and lowest values. Example: data equals 10, 15, 20, 25, 30. Range equals 30, 10 is equal to 20. Variance measures how much data points deviate from the mean. Shows data spread around the average. Standard deviation. Square root of variance. Tells us how spread out the numbers are from the mean. Lower standard deviation means data points are closer to the mean. Frequency distribution and analysis. Frequency distribution. Organizing data into categories or intervals to show patterns. Example distribution. 0 to 10 units sold occurred 5 times. 11 to 20 units sold occurred 8 times. 21 to 30 units sold occurred 10 times. Histograms. Bar charts representing frequency distribution. Show the shape and pattern of data distribution. Help identify normal distributions, skewness, and outliers. Correlation analysis. Positive correlation. As one variable increases, the other also increases. Example, higher advertising spend typically leads to higher sales. Negative correlation. As one variable increases, the other decreases. Example, more machine breakdowns lead to lower production output. No correlation. No clear relationship between variables. Example, employee shoe size and company revenue show no correlation. Understanding correlations helps predict business outcomes. Regression analysis. Purpose. Estimates relationships between variables to make predictions. Helps forecast future outcomes based on historical data. Simple regression equation. Y equals A plus BX. Y equals dependent variable, e.g., sales revenue. A equals intercept, constant starting point. B equals slope, rate of change. X equals independent variable, e.g., advertising spend. Example. If Y equals 50 plus 2x, and x, advertising spend, equals 10. Sales revenue prediction equals 50 plus 2 by 10 equals 70. Index numbers. Purpose. Compare data over time relative to a base period. Show percentage changes from a baseline. Formula. Index number equals current value divided by base value times 100. Example. Base year sales equals $50,000. Current year sales equals $60,000. Index number equals open parenthesis 60,000 divided by 50,000 close parenthesis times 100 is equal to 120. Interpretation. Sales increased by 20% since the base year. Moving averages. Purpose. Smooth out data fluctuations to identify underlying trends. Remove short-term variations to see long-term patterns. Formula. Moving average equals sum of values in period divided by number of periods. Example. Sales over 3 months, 100, 150, 200. 3-month moving average equals open parenthesis 100 plus 150 plus 200 close parenthesis divided by 3 is equal to 150. This smooth value reduces the impact of monthly fluctuations. Probability in business decisions. Probability definition. Measures the likelihood of an event occurring. Expressed as a number between 0 and 1, or as a percentage. Formula. Probability equals number of favorable outcomes divided by total possible outcomes. Business example. If a company has 5 defective products in a batch of 100, probability of selecting a defective product equals 5 divided by 100 is equal to 0.055%. This helps in quality control and risk assessment. Thank you for watching. You now have the tools to collect, analyze, and interpret data effectively. These statistical techniques will enhance your ability to make evidence-based management decisions. In the next video, we'll explore how to apply these analytical skills to cost accounting techniques.